Hello, everybody. Can you see me? Let's see. I think it's pretty neat. Hello, everybody. Today we have a problem before us. A problem. And what do we do to problems? We attempt solving them. So the problem we have before us is square root of 2 is irrational. Proof. Prove that the square root of 2 is irrational. So before we get into this mathematical proof, the word irrational, from a mathematical point of view, irrational numbers are numbers that cannot be expressed as a ratio of two numbers. For example, so we have x, that if x is equal to a over b, integer a over integer b, then x is rational. But if x is not or cannot be expressed as a ratio of two numbers, it's not rational. That means it's irrational. Now we are asked to prove that the square root of 2 cannot be expressed as a ratio of two numbers. That's what we're asked to do. So let's get into the proof as fast as possible. Now, let's assume the contrary. So we're going to take a proof by contradiction approach. The proof by contradiction, we're going to assume the contrary. Let's assume that the square root of 2 is rational. So, square root of 2 is rational. That's one. And that it's been reduced to its lowest form of rationality. So let's say if it's rational, so we say we could just assume a over b for some a and b for some integers a and b. And this has been reduced to its lowest form of rationality. Let's say 1 over 2. So it's been reduced. That means the numerator and the denominator, they do not share any common factor. I repeat, they do not share any common factor. So let's proceed from there. Remember, the first assumption is that the square root of 2 is rational, and it's been reduced, the second one, to its lowest form of rationality. For example, 1 over 2, for example. Now, why do we take this approach? The reason why we've taken this approach is, think for example, we progress with this proof, and then we get like our final answer, or the progress we're making points to our assumption. That means square root of 2 is indeed rational. But then if we should obtain something that looks fishy, then it's irrational. Then the proof is true. So let's progress. So the square root of 2 is rational. That's the assumption. This means that we can progress by taking the square root of the square of both sides. So this would be the square root of 2 is this. So we're going to take the square of both sides, and this would cancel the square root. This is like 2 to the power of 1 over 2. So it's another way of expressing this. So, and yeah, so it cancels. And then we have that 2 is equal to a squared, b squared. So progressing with the algebra, let me get this out of the way. We have 2b squared is equal to a squared. So looking at this gentleman here, we figure out that a must be even. Why would I claim that a must be even? Because a has like 2. A is equal to b squared. And if a is equal to 2b squared, that means a must be even because of the 2 here. Every even number has 2, as every positive even number has the number 2 as its factor. So for example, 2, 4, 6, 8, and so on and so forth. So if a is even, so say a is even, every even number can also be expressed as 2 times an integer. So if a is even, we can say that a is equal to 2 times, let's call it integer c. So this is a. If this is true, which it is, we can comfortably write that a squared is 2c all squared which would give us 4c squared. Yeah, so one thing we've obtained from all of this, all of this exercise is that a is even. That's one. So let's progress. We also saw from here that a squared is equal to 2b squared. That means it still continues. So we're going to go up here and we're going to say that 4c squared it's equal to 2b squared. Oh, where did the 2 go? So if we have like a common thing, that's 2. So 2 is going to cancel out, and we have that 2c squared is what? It's b squared. This also means something. It means that b is even. So we've just seen that a is even and b is even. But remember, guys, from our assumption from the onset, we assumed that the square root of c is rational and has been reduced to its lowest form of rationality, like the lowest form of rationality, example 1 over 2. If that was our assumption, and we are obtaining, we're having like two even numbers. We're having that a is an even number. That means a is an even number. It's an integer. Let's say, let's a is an even number. Yeah, let me stop there. And b is also an even number. Let's say 4 over 2. And these contradict our initial assumption. Hence, the since uh, a since okay, let's say since a is an even integer, since a and b are, so let's say since a and b are even integers, blah blah blah. This contradicts our assumption, hence the square root of 2 must be irrational or it's irrational. And that's the end of our proof. So that's the end of the video. That's the end of this proof. If you don't mind, please hit the subscription button, like the video. I'm on a quest on becoming a scientist. And yeah, so one way I aim to and desire to support myself is by making content and solving mathematical problems on YouTube. So thank you very much, and I hope to see you in my next video. Thank you.